Now, what we want to do is have a look at what happens to our graphs when we start to add some negatives in front of the function, or we want to take the absolute value or take the function of the negative value. So let's consider x squared here. So we know what x squared looks like. We've got this curve, parabola, looking like that. What happens when it's minus x squared? What happens to it? Well, all the y values, when you put a negative there, all the y values that were positive now become negative. So you can see that it has the effect of reflecting everything in the x-axis there. So what was above the x-axis is now below the x-axis. If we did have something that was below the x-axis, so the values were negative to start off with, they'd become positive. So you just reflect everything in the x-axis. So, for example, function of x, natural log of x here is our function, and then negative of the function. So we draw natural log of x up first, and then just reflect all the values. So what was negative now becomes positive, and what was positive now becomes negative. So it has that effect. So, and this is an easy way to do it. Sketch the function of negative x. So negative of the function of x. We sketch the function of x and just reflect it. That's the easy way to go about that every time. So minus e to the x. So there's e to the x, and reflect it in the x-axis. Negative of x cubed, well, the blue is x cubed, and then it just gets reflected. What was negative now becomes positive, what was positive now becomes negative. Negative sine of x, well, the red here is sine of x, and the pink then is negative sine of x. So everything's just been reflected there. Now, for absolute value, what basically is the same idea, except all we're reflecting is what's below the x-axis, because basically everything that was positive stays positive when it's a function, absolute value function, and anything that was negative now becomes positive. So if we have a look at sine of x here, the blue was sine of x. You can see it's turned to a purpley colour because the pink and the blue are combining there. Now there's our blue there going through that part. But now, what was positive stayed positive, so they were positive parts. So you can see a purpley type colour where it's staying positive, and what was negative now becomes positive. So it gets basically this bouncing effect of the function. So it comes down, it'll come in sharp because it's meeting that way, and that's being reflected up there. So anything that was positive stays positive. Anything that's negative now becomes positive. So square root, absolute value of x squared minus 5. So x squared minus 5 would have looked like that. So it would have gone through minus 5 there. So it gets reflected and goes through 5 there. So it comes down and it's going to be sharp. It won't turn nicely. They don't turn very nicely. They go and they are sharp values there. An absolute value of natural log of x. So instead of coming up here and going smoothly there, it'll come down now and sharply and bounce off into that direction. Absolute value of 2 on x, well, normally it'd be in the first and third quadrants, but now what's in the third quadrant gets reflected back up to the second quadrant. So what about the function of negative x? Well, basically what we're doing, instead of putting positive values in there, we're going to put the negative values in. So in this case, what was negative now becomes positive. So in that idea, that the graph here starts to reflect in the y-axis. So all the values that were positive now become the negative values. So using natural log of minus x, we draw natural log of x up first, and then we reflect it in the x-axis, because basically we're putting in what was minus 5, what's now minus 5 is minus of minus x, so it would have been 5, so whatever the value of natural log of 5 would be. So that's how we do these ones. So 3 to the power of minus x, so the function's being changed. We know that, we've done those ones before, we know that that's going to give us that function there. Minus x minus 2, so if we draw x plus 2, what does that look like? And then square it, and that's where we get those values. So given this function here, so without any values, so we don't know what the values are, can we draw up the other ones? Now, on your notes, you need to make a change, because The first one's an error because minus of the function x will reflect this function in the x-axis. So what was above the x-axis now goes below. What was below the x-axis now goes above. So it should look like that, not like that. Hopefully you realise what that one should be. The absolute value, what was below, now goes above. And function of minus x gets reflected in the y-axis. So what was above that side, onto the right of the x-axis, now is to the left. And that would swap over as if in the same situation as well. So there we go. That's what our functions start to look like when we do this situation. Now, keep in mind that what you're going to have is some rules to follow when faced with certain situations. Now, we've given you 3 rules with this one. So what happens when it's a minus of a function? What happens if it's an absolute function? And what happens is function of a minus x. There's some simple things we just have to keep in mind, that if we know how to graph the function, then it's easy to graph a manipulation of that function in one way, shape or form. And we'll look at others as we go through this topic, but that's how we start to do, that's the first lot we start to manipulate. Not hard manipulations, but if you can remember what to do, it makes life easier because you know how to draw the functions that we've got anyway.